Hi guys, today I'm going to explain you about the first chapter of data structure, that is introduction and overview. So part A is contains this many topics. Part B will be released in next video, which consists of control statements, asymptotic notations. So part A topics are definition, advantages, types of data structure, that is primitive data type and non-primitive data type, major operation, abstract data types, complexity of algorithm and characteristics of algorithm. So what is data structure? A data structure is a way of organizing data in a so that it can be used efficiently. So the advantages of data structure are efficiency. If the data structure for implementing a particular ADT is proper, then it makes the program very efficient in terms of time and space. Time and space complexity you'll learn in upcoming PPTs. Uh, Reusability, where the client multiple client programs can reuse the data structure uh, efficiently. Abstraction is where hiding the inner details and providing the data details which is necessary for the audience or client, that is interface. So the types of data structure are primitive data type and non-primitive data type. Primitive data type consists of char, float, double and pointer, and it can hold only a single value. Non-primitive data types are two types: linear data structure and non-linear data structure. So the arrangement of data in a sequential manners are called a linear data structure. For examples, array, linked list, stacks and queues. And this array, linked list, stacks and queues elements can be accessed by using their index number. In this data structure, one element is connected to another element in a sequential manner. A non-linear data structure is where one element is connected to n number of elements. So the best example is trees and graphs. So data structure can be classified into two types: static data structure and dynamic data structure. So static data structure is where the size is allocated at the compile time, therefore the maximum size is fixed. It can not be flexible. So dynamic data structure is where the size is allocated at the runtime process, and therefore the maximum size is flexible. So here you can see the data structure classification. So data structure is divided into two: primitive data type and non-primitive data type. As I told before, primitive data type consists of integer, float, characters and pointers, and non-primitive data types consist of arrays, list, files. So list is divided into linear list, non-linear list, and stack is divided into stacks and queue. Sorry, linear list is divided into stacks and queue. Non-linear is graph and trees. So integer means it can not hold any point value, that is 0.0. No, it only holds only a single value. And float can hold double values, that is 0.0 f. So for implementing a float, we should use 0.0 f. And character is only one single character, that is a, b, c to z. And pointer is where it holds the address of the next variable. Pointer you will learn in upcoming chapters. So arrays is uh, where you can store a large number of elements into a single character. And list is divided as linear list and non-linear list. So stacks is left in first out, and queues first in first out, which you'll learn in upcoming chapters. And graphs and trees are interconnected with one element as well. One element is interconnected to many elements. That also you'll learn in graph and tree chapters. So, major operation performed on data structure are searching, sorting, insertion, updation, deletion. So, searching is where you search a particular element in a data structure, and sorting is where you can sort the data elements in the data structure according to your wish. That is either ascending order or descending order. And insertion is where you can insert a new element into a data structure. Updation is where you can replace an element with another new element. And deletion is where you can remove an element from the data structure. So what is abstract data type? The process of providing only the essential details and editing the implementation details is called abstraction, where the developers only provide essential details, what is required by the user, that's all. They don't provide about what they use or what they use for developing the particular program or code that is all not required for the user. So they hide only the um, implementation detail and provide only the essential details for the user. So there are two types of complexity of um, algorithm, that is complexity and space complexity. Is time complexity is where amount of time needed by the program to complete its execution. So best, there are three cases: best case, average case, worst case. Best case where it takes only less time to complete its execution, that is minimum time. And average case is where it is neither more or nor less, it's neither maximum nor minimum, so it's average case. And worst case is where it takes lot amount of time, that is maximum amount of time required to complete its execution. Space complexity, where the amount of memory needed to complete needed by a program. So there are two types of memory: fixed size memory, variable size memory. Fixed size memory is static, and dynamic data type, that is variable is dynamic size memory. So, fixed size memory is where it is used for variables, constants, instruction, and fixed size array. Variable size memory is where the memory is allocated at the runtime, that is dynamic. And what is an algorithm? An algorithm is a step-by-step procedure for performing some task in a finite amount of time. So, for example, for cooking, you write down some instructions before cooking, right? That instruction is known as algorithm. So, for example, you want to prepare a coffee. So you'll write note down the instructions. So first, you'll put on the flame, put the pot, then add milk, water, then to another glass you add coffee powder and sugar. Then you mix it. So that instruction you write down is, that is algorithm. So what is the characteristics of algorithm? So each instruction of an algorithm should be precise and understandable and clear. So next is each instruction should be performed in finite amount of time. So each instruction, so the instruction issue you give, for example, I want to continue till 9. So int I is equal to 0, int I is lesser than 10. So it should repeat up to 9 number of instructions. Then algorithm must have finite number of steps. No step should sorry. Algorithm must have finite number of steps. So algorithm no, should have minimum number of steps or maximum number of steps. It should be precise. That is, it should be finite. Consist of finite number of steps. Then no instruction should be repeated infinitely. That is, instruction should not be, the particular instruction should be not be repeated again and again. So so instruction should be mentioned only once. An algorithm must have 0, 1 or more input value, where an algorithm must produce at least one output value. Thank you. Part B will be released soon.